now we will move for the derivation of the expression to get the time required to empty a reservoir or any tank with a rectangular notch, and the further on we will go for the triangular notch. So let's start discussing. So consider a reservoir or tank is having a uniform cross sectional area. So for the derivation of such equations, assumption is involved that this particular tank is having a uniform cross sectional area, that is your A, and that is the thing we have always involved in the our previous equation. So with having a uniform cross sectional area of A such that the length of the crest of the weir is L. So L is your length of the crest of the weir. And now once the tank will be getting emptied, this particular phenomenon will require some time. So at the initial height of the liquid above the crest of the notch, we have to considering that this is your h1. So h1 is your initial height of the fluid or liquid you are considering. So usually this is water, so this is the fluid above the crest of notch. And after time t that is involved for emptying in the tank, so after this some time t, this the same final height of the liquid of the crest is your h2. So you can say that final height of the fluid above the crest of the notch h2, and the time required which took for making this particular change from h1 to h2 is t. So this is your time required in seconds to lower the height of liquid from h1 to the height of liquid above the surface at any time of instant is, that is your small h, and small time we are considering that dt. So by this dt, the height of liquid surface that will fall by the distance of dh. So tank is getting empty. So if we talk about that how much water has been emptied is, that is A into dH, that is the volume of the water that is emptied. And if we are saying that discharge rate during this time is Q, and this phenomenon has happened a small interval of time dt, then this will be the volume. However, the tank is getting emptied, so negative. So that particular thing we have to take care, because with the increase in time h is getting decreased. So dh is h2 minus h1, and this h2 minus h1 will be negative. So if we just write the equation of the q value for the rectangular is, that is we have already derived that this is 2 by 3 cd multiplied by l under root 2g and h raised to the power 3 by 2. So we are just putting this equation of q in the previous equation. We can write it as that minus a into dh is equal to 2 by 3 cd multiplied by l multiplied by under root 2g h raised to the power 3 by 2 into dt. So we can just rearrange this equation such that dt is on the left side. This can be written as dt is equal to minus a into dh divided by 2 by 3 cd into l under root 2g h raised to the power 3 by 2. Now if in order to get the total time, once the water is getting from emptied from h1 to h2, so we have to integrate this equation such that this phenomenon is taking from 0 to time t, that can be written as minus a into dh divided by 2 by 3 cd l under root 2g h raised to the power 3 by 2. So most of thing, if you can see, is constant. Only the dh divided by h raised to the power minus h raised to the power 3 by 2 is over there, and this integration will happen from the limit of h1 to h2. So if we integrate the left side, this will become the t, and this will look like minus a, that is comes outside as a constant, then 2 by 3 cd multiplied by l multiplied by 2g, and then this is h1, this is h2, and h raised to the power minus 3 by 2 dh. And again, if we just integrate and just rewrite the equation, this will look like minus 3a divided by 2 times of cd into l into under root 2g, and this is, so if we integrate h raised to power minus 3 by 2, this will be h raised to the power minus 1 by 2 divided by minus 1 by 2, and our limits are h1 to h2. Now and then now we have to put the limits, and once we'll put the limit and rearrange this equation, this will look like t is equal to minus 3a divided by 2 cdl under root 2g, then minus 2 will come outside, and this will be 1 divided by under root h2 h1, and this will become t is equal to 3a divided by 2 will cancel out, so cd l under root 2g, and then this will become 1 divided by under root h2 minus 1 divided by under root h1. So the final equation we were looking for emptying a tank will look like this one, where the capital T, the time took when the reservoir is reaching from position of h1 to h2, the time this one. And similarly, if we go for the derivation of the emptying of reservoir having a rectangular notch, we can also derive this equation. So now we will go for the derivation of an expression for the time required to emptying a reservoir with a triangular weir. So considering that tank having a uniform cross sectional area of A is A, theta is the angle of the notch, and similarly h1 and h2 are the initial and final height of liquid above the notch. So we can say that is initial height of water above the notch, and this is final height of water above the notch. And for this particular phenomenon, which takes the emptying of water from level h1 to ht, this particular phenomenon takes time of t. So we can say we can write that this is time required to lower the height from h1 to h2. The height of water in the reservoir from h1 to h2. From h1 to h2. So in the same fashion, what we did earlier, we will go for this one. So let's suppose that any instant the height of liquid surface above the apex of the notch is h. So this h is the height of liquid above the apex of weir. So at instant, and for the small time interval, that is dt, so liquid surface falls by the dh. So we can write that the if the discharge rate at that instant is q, then q, and in the small interval of time dt, so q into dt will be the volume of water that has emptied, and that will be the cross sectional area is a, and dh. So dh is negative as the tank is getting empty, so we can write this equation as this one. Now so quickly we can say that just only that we have to put the expression of q of the triangular notch, and we can quickly solve this thing. So q is equal to 8 by 15 cd multiplied by tan theta by 2 under root 2g, and h raised to the power 5 by 2. So we can write that minus, so we can write that minus a into dh is equal to 8 by 15 cd tan theta by 2 under root 2g h raised to the power 5 by 2 dt. So we can write that dt, as we have to figure out the time required, so dt is on the one side, so minus 8 times of dh divided by 8 by 15 cd multiplied by tan theta by 2 into under root 2g h raised to the power 5 by 2. So the total time which is required can be obtained by just by integrating this above equation. So we can write that dt, and this is having the limit of 0 to t, and as during this, at the moment of 0, the height of water above the crest was h1. However, at the end of time t, the height of crest above the height of water above the crest is h2, and then minus a into dh divided by 8 by 15 cd tan theta by 2 under root 2g multiplied by h raised to the power 5 by 2. Now just integrating this equation will give you the t on the left side, and we can write this thing as minus a divided by 8 by 15 cd tan theta by 2 multiplied by under root 2g, and this is h raised to the power minus 3 by 2, and this is minus 3 by 2, and our limits are h1 to h2. So just putting all these values, we will get it that t is equal to minus 15 into a divided by 8 cd tan theta by 2 under root 2g and then this is minus 2 by 3. So it comes outside, and this is 1 divided by h raised to the power 3 by 2, and this is h1 h2. And if we put the limit values, we will get it that this is 5a. After just simplifying, we'll get this is 5a divided by 4 cd tan theta by 2 under root 2g, and then this is 1 divided by h2 raised to the power 3 by 2 minus 1 divided by h1 raised to the power 3 by 2. So the final equation we are getting for the triangular notch for emptying a tank is this expression. And this particular expression, deriving this particular equation, is very easy task. One can quickly attempt just understanding the basic equation what we are getting from this one. The only thing what we have to do is understanding this particular equation and just putting the value of q for the given shape of the weir. Problem is related with the estimation of the time required for lowering the water level in a reservoir. So other way around, you can say that this is the estimation of time required to empty a reservoir or any tank with any triangular or rectangular weir. So we are taking the problem that is find the time required to lower the water level from 5 meter to 3.5 meter in a reservoir of dimension 95 meter by 95 meter by a rectangular notch of the length 3.0 meter, and the CD value is given as 0.6. So the solution can be obtained by, so first of all, figuring out all the parameters which are given, that is the level of the water, the initial level of the water we are assuming that with the showing of the h1, and that is the 5 meter. So with some time the water level gets to a height of 3.5 meter, that is your h2. Now the dimension of the reservoir is 95 meter by 95 meter, and then we can say the area is coming out to be 95 multiplied by 95, that comes out to be 95 square, that is 9025 meter square. Now the length of the weir is given as 3 meter, so this is the weir length. Now another point which is given to us is CD is equal to 0.6. So we have to use the formula time required to empty reservoir with a rectangular notch. So that is time t can be find out by 3a divided by CD into L into under root 2g in brackets 1 by under root h2 minus 1 by under root h1. Now let's put all the values. So 3a is 9025 divided by CD value is 0.6 multiplied by length of the weir is 3 meter, then under root 2g, that is 9.81 multiplied by 1 over under root h2, that is under root 3.5 minus 1 under root 5. So let's solve this value. So this value comes out to be, so the calculation gives that this is 294.71 seconds. So that is the our answer, that this much time will required to reach the water level from a height of 5 meter to 3.5 meter using a rectangular weir of having this much size, and this is the CD. So our next problem is similar to the previous problem. So instead of a rectangular notch, a right angled V notch is being used, and we have to figure out the time required for the change in the level of water in the reservoir using the same data. So let's go for the solution of this problem. So all the data, because this is a right angle V notch, so theta is equal to 90 degree, and here h1 was 5 meter, h2 was 3.5 meter, and the area, which was 95 multiplied by 95, that was 9025 meter square. uh, I guess I'm right, yeah, 9025. And then the another thing that it's asked is that CD value is 0.60. So we will use all the data which is available over there in the formula for the time required to empty a reservoir with a triangular weir. So that is T is equal to, instead of 3a it will be 5a divided by 4 times of CD multiplied by tan theta by 2 multiplied by under root 2g, and then 1 over h2 raised to the power 3 by 2 minus 1 over h1 raised to the power 3 by 2. So let's put all the values over here. So T is equal to 5 multiplied by 9025 divided by 4 into CD value is 0.6 multiplied by tan theta by 2, that will be the tan 45, and tan 45 is 1, and under root 2 into 9.81 divided by 1 over this is 3.5 raised to the power 3 by 2. So we can write it as a 1.5 minus 1 over 5 raised to the power 1.5. So let's quickly solve this equation. So the calculation gives this value as 268.78 seconds. So this is our answer. So you can see the difference. The earlier answer was 294.71 seconds. However, this answer is 268.78 seconds. So let's take another problem. So that says that a right angle V notch is inserted in the side of tank of length 4 meter and width 2.5 meter. Initial height of water above the apex of the notch is 30 centimeter. Then it is asked that to find the height of the water above the apex if the time required to lower the head in the tank from 30 centimeter to final height is 3 minutes. We have to take the CD value as equal to 0.6. So before doing this problem, first of all, we need to understand what is being asked. So what exactly is the scenario is that the initial height in the channel is, in the weir is given to us, and after the 3 minutes it reaches to a new height of this one. So this value is known. Only this value is asked if it is given that this much time takes a 3 minute. So in the 3 minute, how much the lowering of the water level will be happen in the case of the V notch. So that's what we need to require. So this value is your h1 and this value is your h2. So in this equation, h2 is unknown, and however the h1 value is already given to us. Now once you are able to figure out the meaning of the question, that it's very easy for us to solve the question. Now again we will have to use the expression of the t, and all the other values are given to us, only this h2 is unknown, and we can quickly solve this problem. So the problem is such that theta is equal to 90 degree, because right angle notch, and then area of the channel, that is A is equal to 4 meter multiplied by 2.5 meter. That comes out to be 10 meter square. And initial height above the apex of the notch is, that is your h1, that is your 30 centimeter, that means it is 0.3 meter. And the time required for reaching a level of another final height, that is we are assuming that h2 is 3 minutes. So 3 minutes is equal to 180 seconds. That's all. So also the CD value is 0.6. So only we have to write the formula required to empty a tank using a triangular notch. So that equation, that is T is equal to 5 multiplied by A divided by 4 CD tan theta by 2 multiplied by under root 2G, and in brackets 1 divided by h2, that is unknown to us, h2 raised to the power 3 by 2 minus 1 divided by h1 raised to the power 3 by 2. Now you have to remember this thing, that h1 is already given to us, only this h2 we need to figure out. However, the time is also given to us. So let's quickly put all the values. So t is equal to 180 seconds, 5 multiplied by 9, this is your 10 divided by 4, CD is 0.6, tan theta by 2 will be 1, and multiplied by under root 2G. So under root 2G, if you count, this is coming out to be 4.4294 multiplied by 1 over h2 raised to the power 3 by 2 minus 1 over h1 is given to us, that is the 0.3 raised to the power 1.5. The only thing we have to solve this problem just in order to get the h2 value. So h2 will be, so after calculation this value is coming out to be 0.7, sorry, this is 0.0797 meter. So we can write it as a 7.97 centimeter. That is the our answer for this problem. That's all for this problem.